All right, 7th grade, this is going to be your lesson. We're going to continue. Yesterday we did simple events when one event actually happens, but today what we're going to do is compound events. And I am on page, oh goodness, 64, I believe. Okay, I need to update mine. Please make sure that you're updating this. I'm probably going to do a surprise journal check. All right, so what we're going to do today is talk about, I'm going to use some colored pens here, probability of compound events. And we know that in English, when we talk about a compound sentence, it means that it's more than one sentence. And so, same thing in math. When we have a compound event, that means that there's two or more events happening. And we briefly discussed this when we were talking about sample spaces yesterday, when we were talking about the spinners, okay? Yesterday, all we were doing was we were talking about the total possible outcomes, which is going to be at the bottom of our number, remember, the probability. So it was important to understand the tree diagram, because that's going to help you today. So yesterday we talked about a simple event. And yes, the 8th graders are in here talking very, very nicely today. So a simple event is the probability of an event happening one time. That's it. And we simply, as we talked about yesterday, is the favorable and then divided by your total possible. Okay? Now, today we're going to talk about a compound event. And we will practice this when you come to me tomorrow. It is the probability of one event, another event, or more. Okay, it can be more than two, but it is more than one event. Okay, remember you can always pause the video. I know sometimes I write fast. Now, when you have a compound event, just like we found out yesterday, and we discovered that, yeah, all we're going to do is we're multiplying the numbers. You think of the word, oh, bad pen, sorry. You're going to think of the word you multiply. Okay? Always remember that. Now, for example, we're not going to go into the other one, but we are going to talk about an independent. When these two events are independent of each other. In other words, one does not depend on the other. And we call that with replacement, or maybe you have a spinner. Okay? And I'm going to talk about what that means, and you'll understand it, especially after tomorrow. But it's when the outcome of one event does not affect the outcome of another event. Okay? Okay, now what I want you to do, we're going to write on the left side because we're going to add some more notes here, but I don't want to do it today, okay? So what I want you to do is go ahead and I'm going to close my book. You can go ahead and pause this. I'm going to close it, and I'm going to start on the top here. And so what I want you to do is I want you to think of a bag of marbles. I know some of you are not good artists, but we can try, right? All right, so I have a nice little bag of marbles. Okay, so I want you to think of I'm going to add, in my bag, I have a blue marble. Okay, and by the way, you might want to pause this and go ahead and get 3 colors, a pink, green, and blue. Pink, green, and blue. It can be colored pencils, it can be markers, whatever you would like. I want you to put in 2 green, and then we're going to add 3 pink striped. Okay, so we have 3. We have a blue marble, and then we have a green, and we have a pink striped. Okay, all right, so this is going to give you an example of, sorry, trying to find my pen. What we want to do is we want to find the probability of, let's do a blue. Probability of a blue. And we know, how many blue do I have in there? I have 1. And how many total marbles do I have? 6. So this was a, what? A simple event. 1 time pulling out a marble. Okay? Now, what if I do the probability of a blue marble? In other words, I'm going to reach into that bag, pull out that blue marble. What is the probability of that? I'm going to leave some space here, please. Okay? We know, we just found out, was 1 out of 6, right? Now what I want to do is, so I pull a marble out, okay? But whatever marble I pull out, I'm going to put it back in. And now I want to know, what is the probability after that of pulling a pink stripe one? So think about this one though. What is the probability of a pink striped? We know that the probability of a blue is 1 out of 6. But the pink striped one, I have a, you know the bottom's going to be 6, right? But what is the probability? It's 1, 2, 3, right? That's how many are there. And what did we say that we're going to do with these 2 events? We always multiply. And yes, you have to multiply fractions, and that's why fractions are so important, everybody. So it's top times top is 3, and 6 times 6. Please don't say 12, because what are you doing when... That's right, you just added. 6 times 6 is 36. Okay? Now I know that these 2, and here's a little trick. If you want to know if a number is divisible by 3, add up each number. 3 plus 6 is 9. Is 9 divisible by 3? If it is, then 3 is a common factor. So 3 divided by 3 is 1. 36 divided by 3 is 12. So what does this mean? All I did was simplify it, but it means that the probability is 1 out of every 12 times that I try and pull a blue one, put it back, pull out a pink one. It'll happen 1 time where I pull out a blue one and then a striped one, okay? So out of every 12 tries, that should happen 1 time. Now that's theoretically. Does that always happen? No. Okay? Now let's do one more. Let's pretend that I want to find the probability. I want you to do these 2 by yourself. Okay? So what we're going to do is we're going to find the probability of a pink striped one, and then I want you to find, remember this is a compound event, of a green one. And then at the bottom, I want you to find the probability of a blue one, and the probability to then pull out a red one. Yes, that was a trick question. All right, I want you to pause it. Think about those two. Try and solve it. Yes, I'm going to keep on going, but I want you to try and do it yourself. So please pause this. All right, now I'm going to give you the answers. The probability of a pink one, pink striped one, we know is 3 out of 6. Can I reduce it to 1/2? Absolutely. The possibility of a green one is 2 out of 6. Now, it's a lot easier to go ahead and simplify these now, or you can simplify it at the end. It's your choice. And I know that I always multiply. So 3 times 2 is 6. 6 times 6 is 36. And I know that these are the numerator and the denominator are divisible by 6. That is a common factor. 6 divided by 6 is 1. 36 divided by 6 is 6. Okay, so the probability is 1 time out of every 6 times that I try and pull out a pink stripe one, then pull out a green one. But remember, we're always putting back the first marble. Put that back in the bag. Now, probability of a blue one, we know is 1 out of 6. Guys, what is the probability of pulling a red one? It's 0. In other words, if you ever have an event that just can't happen, the probability is 0. Can't happen. All right? So what I want you to do is get out this back sheet right here. And what they're talking about is compound events. Okay? So think about a coin. We're looking for the probability of a head off of a coin. We know that that can happen 1 time out of what is a possibility? What are the total possible on a coin? 2. Amani. So it's 1 out of 2. What is the probability of? Then you have a die, and they have 6 possible. What is the probability of rolling a 3? How many times? What is how many times do you see a 3 on a die? Just 1 time. So top times top is 1. Bottom times bottom is 12. Your answer is A. Okay? All right. This one's a little hard. If you have 2 cards that are selected from a deck of cards, okay, I don't want you to do this one. Skip that one. We're going to talk about that tomorrow. All right. I think you can do this one. I'm going over which ones that I feel that you can try. All right. Think about that one. A little tricky. You can do this one. Think about this one. And you can do this one. Okay? All right, so don't stress about this. I am not going to grade it, but I do expect to see it done. I want to see what you think, what you know, and how you would attack that problem. So in other words, I want you to be able to engage in the discussion tomorrow as soon as you walk in. All right? Good luck. See you tomorrow.